बोले तक मैं दिख रहा दिख रहा है केमिकल रिएक्शन ऑफ जोर से टुडे starting chemical reaction of haloalkanes. So there are three types of reactions happen here. First one is the so here we study about the chemical reaction of haloalkane. Mainly there are three reactions happen: nucleophilic substitution reaction, elimination reaction, and reaction with metal. Okay, so we first starts nucleophilic substitution reaction. So we know that substitution reactions happen only in single bonded. If the double bonded is there between the atoms, in that of reactions, addition reactions is possible. So here we are studying nucleophilic substitution reactions. That means replacement, yeah, displaces of one type of a species to the other. So here we know the definition of nucleophilic substitution reaction. That means here we study about the reaction of alkyl halide with the nucleophiles, yeah, nucleophilic. So the definition of nucleophilic substitution reaction is in this reaction attacking nucleophile replace the other nucleophile which is connected to the molecules. That means in alkyl halide, halide ion, which is also called the leaving group, which is attached to the molecule, is replaces by the attacking nucleophile. That means here is the substitution occur. Suppose we take an example. Rx plus nucleophile, this gives the product RU NU X minus. Here is the halide ion which is also as living group, living species, and this one is the attacking nucleophile. So here, that is the alkyl halide, also known as haloalkane. In this reactions, this is the substrate and this is the reagent. So here reagent is the attacking nucleophile which attack, because R is the polar compound. So here X is the partially negative charge and R is the partially positive charge. So here nucleophile attacks this atom, and X, that is known as halide, which is living from here. So a strong nucleophile replaces the weak nucleophile. X minus is also in the nucleophile which is weaker than Nu minus. अब here we study nucleophilic substitution reactions are mainly two types. Mainly two types. So nucleophilic substitution reactions are mainly two types: substitution nucleophilic unimolecular, and second is the substitution nucleophilic bimolecular. Substitution nucleophilic unimolecular is also known as sn1 reactions, and substitution nucleophilic bimolecular is also known as sn2. So we will study serial wise. First one is the sn1 reactions. sn1 substitution nucleophilic unimolecular. These reactions is carried out in polar protic solvents. Some points: these reactions are carried out in polar protic solvents. Here we know first of all polar protic. What is the polar protic solvents? Those solvents which form H form, hydrogen form bonding, is known as polar protic solvent. Mainly these are two types of solvents: polar protic, and second one is polar aprotic. Here, for sn1 reaction, polar protic solvent is carried out. So first of all, know what is the polar protic solvent. Polar protic solvent, that means which form hydrogen bonding. That type of solvent is known as polar protic. That is, suppose OH, NH, FH. These three form hydrogen bonding. These three types form hydrogen bonding. So these are the polar protic solvents. Polar aprotic, which all are polar compounds, all are polar molecules where form hydrogen bonding, H form. Polar aprotic, which does not form hydrogen bond, that is known as polar aprotic. So here they take some examples. Polar protic solvents, that is H2O, which form hydrogen bonding. Alcohol, which form also hydrogen bonding. NH3, which also form hydrogen bonding. Inorganic, mainly though two are used mainly, OH and NH. These two are the main polar protic solvents. FH is also a polar protic solvent, but first of all it is condensed in liquid form, then used as a solvents. So mainly inorganic, two are OH and NH. OH, H2O, alcohol, NH3. So these are the polar protein. Where forms hydrogen bonds, that type of solvent is known as polar protein. Which doesn't form hydrogen bonding, that is polar aprotic. Take some examples. These solvents are polar aprotic solvents because these are not forming hydrogen bond. Dimethyl ether, dimethyl sulfoxide, tetrahydrofurone. This name THF. This is called THF, tetrahydrofurone. So these are the polar aprotic. That means which doesn't form hydrogen bond. Air is not connected directly to hydrogen, so this doesn't form hydrogen bond. So here we are studying polar protic and polar aprotic. So SN1, we know, here we write for SN1 polar aprotic solvent is required. Then deeply study about the SN1 reaction. SN1 reactions mainly occur in tertiary halide. We also know primary halide, secondary halide, tertiary halide. In SN1 reaction, some points are there. So we write these reactions So here are some points about the SN1 reaction. Mainly, these reactions occurred in two steps. Here, formation of carbocations. The rate of that means that is very important. The rate of reactions SN1 depends upon the concentration of one of the reactant. That is our next one is the reactivity of SN1 order reactions is tertiary halide, secondary halide, primary. Because here is the in SN1 reaction formation of carbocation. So we know that the order of carbocation is 3 degree, 2 degree, 1 degree. So tertiary halide is more stable than secondary, is more stable than primary. So the order of reactivity tertiary halide, secondary halide, primary halide. Here we take examples to is the SN1 reaction. Suppose take an example CH3 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 Br is react with OH minus as give a product CH3 C OH CH3 CH3 and Br minus. So here we take the tertiary halide. Here is the tertiary halide and react with reagent OH minus, which is the attacking nucleophile, and give a product this one, and Br minus is the leaving group, also known as halide ion. So here we are studying how this is happened, that is mechanism. So here we start mechanism of these reactions. First of all, here C-Br bond is breaking, and that step is very slow because these reactions are happened in a polar protic solvent. That is the here is the solvation occurred. So this process is very slow. So first of all, in first step, formation of carbocation. That is the step first, and CH3, C, CH3, CH3 plus Br minus. That is the first reaction, first step, or this step is slow. This step is the slow. Second step, CH3, C, CH3 plus OH minus. Or this one is the first step, because here is the stable carbocation, complete positive charge, and this one is the attacking nucleophile. So here attraction is more, and these are happen very fast. So the product is the CH3, CH3, CH3 and OH, and this is the first and second step. So here we these are the two steps. Step one, first of all, breaking the C-Br bond, and that is slow. And rate determines. Rate determining step is the step first, because we know that slow step is the rate determining step. So here SN1, that means rate depends upon the concentration of one reactant. That is the rate depend upon this substrate, not the OH. SN1 means Rate depends upon the one of the concentration of reactant, that is substrate. If substrates are more stable, that means formation of carbocation. Okay. There are some compounds which is the halogen group. Here we here in this process order of sn1 reaction. That means in this case, in this type of process, which is first preferable for sn1 reaction. So we know that in sn1 reactions, formation of carbocation. So where is the carbocation is more stable, that is preferable first. So here, if we break the CX bond, then this here is the plus because X is bonded to this carbon. In that case, here is the plus because here is the bonded CX bond. In this case, here is the plus. So here is the carbocation. Here. अब here we choose which one is the more stable. So here that is the resonance stabilized. In that case, resonance is there, but in these two, resonance is not there. So this is stabilized by resonance, and these two are stabilized by hyperconjugation, alpha hydrogen. So in these two cases, alpha hydrogen, and this case, resonance stabilized. So the order of SN1 reactions here occurred first. Order is the A. In these two, more alpha carbon in that case C, because this is the carbocation. Here is the alpha carbon and here is the alpha carbon. So here two hydrogens and here three hydrogens. Total 5 alpha hydrogen is there. But in that case, alpha hydrogen is there, only 2 alpha hydrogen. So we know about hyperconjugation, more alpha hydrogen, more stable. So C is the more stable than B. So the order is A greater than C, C greater than B. This is the preferable for SN1 reaction.